In this video, we're going to talk about L'Hopital's rule by answering the following question. Find the limit in each case. First, the limit as x goes to 1 of x minus 1 over ln of x. And second, the limit as x goes to 0 of sine of x times ln of x. Let's go over L'Hopital's rule. L'Hopital's rule states that if either the limit of f and the limit of g are both 0, or if the limit of f and the limit of g are both infinity, and it doesn't matter whether they're positive or minus infinity, then the limit of f over g is the limit of the derivative of f over the derivative of g. Let's answer the first problem. So we were asked to find the limit as x goes to 1 of x minus 1 over ln of x. Let's look at the limits of the numerator and denominator separately. The limit of the numerator is 0, and the limit of the denominator is also 0. So L'Hopital's rule tells us that the limit of the top over the bottom is the same as the limit of the derivative of the top over the derivative of the bottom. Evaluating each of these derivatives, we get 1 on the top and 1 over x on the bottom, which means that this is the same as the limit as x goes to 1 of x, or just 1. And that's our answer to this part of the problem. Now let's deal with the second part. We were asked to find the limit as x goes to 0 of sine of x times ln of x. Let's look at the limits of each of these factors separately. So sine of x goes to 0 as x goes to 0. And ln of x goes to negative infinity as x goes to 0. It doesn't seem clear where we can use L'Hopital's rule here. We don't have that these two factors have the same limit, and in fact, we don't even have a fraction here. But we can use a trick that will let us apply L'Hopital's rule. We'll take one of these factors and put it in the denominator of the denominator. So we haven't actually changed the expression here, we've just rearranged things so that we now have a fraction. And now if we look at the limits of the numerator and denominator, ln of x still goes to negative infinity, but now 1 over sine of x in the denominator goes to positive infinity. So we can apply L'Hopital's rule to this limit and take the derivative of the top and bottom separately. Evaluating each of these derivatives, we end up with this expression, which simplifies to minus sine squared of x over x times cosine of x. Let's continue on a new page. We were asked to find the limit of sine of x times ln of x, and we found that that was equal to the limit of minus sine squared of x over x times cosine of x. Now let's look at the limits of the numerator and denominator separately. The numerator, minus sine squared of x, goes to 0 as x goes to 0. And the denominator, x times cosine of x, also goes to 0 as x goes to 0. So we're going to have to apply L'Hopital's rule again to this to take the derivative of the top and bottom separately. Evaluating each of these two derivatives, we get minus 2 sine x cosine x on the top, and on the bottom we get cosine x minus x sine x. Let's evaluate the limits of the top and bottom separately one last time. The limit of the numerator, minus 2 sine x cosine x, goes to 0 as x goes to 0. And the limit of the denominator as x goes to 0 goes to 1. Which means that this time we actually get to plug in these limits, and we end up with 0 over 1, or 0. And that's our answer to this question.